Unit 16, Day 1. Factoring with GCF. Okay, so factoring with the greatest common factor. Right now, greatest common factor is basically just the biggest number that will go into two things. And if that means that we have to start looking to variables to be the biggest number, then we just deal with that. Now, number one says 6y to the fourth equals 2y times something, and it's looking for the missing part. Now, we all know that 2 times 3 equals 6. Alright, now y times y to the third equals y to the fourth. It's that simple. Alright, now, on number 2, 3 times, as we all know, 3, and a squared times a by itself, and b squared times b squared will equal 9 to the third, b to the fourth. 3 times 3 is 9, a times a squared is a to the third, and b squared times b squared is b to the fourth. Alright, now number 3, 7 times something, 7 times negative 5 equals negative 35. And then x squared times x is x to the third, y to the 1 times y to the fourth equals y to the fifth. So 7 times negative 5 is negative 35. X squared times x is x to the third. Y times y to the fourth is y to the fifth. And there we have it. Alright, now number 4. We've got 36 equals, well, let's see. 2 times 6 equals 12. 12 times 3 equals 36. Alright, now let's start counting up some exponents here. So we got m to the third. We need to get to m to the fifth. Alright, so that's going to be m to the second. And then we've got n to the 1, n to the 5, that's n to the sixth. So we just need one more n. And there we have it. That problem is finished. Alright, now let's see. Next problem. Number 5. It says to find the greatest common factor if the given monomials, alright, of the given monomials, sorry. Alright, so number 5 is 17a and 34w. Now, if you'll notice, neither of those have a common variable. But what is in common is the fact that 17 and 34 are both divisible by the same number, 17. Okay? 17 goes into 17 once, 17 goes into 34 twice. And there we have it. Alright? So we're looking for the biggest thing that will go into both numbers. Alright? Now, on number 6, you'll notice 11 and 40. There is nothing that will go into both 11 and 40. Here, if we come over here to the side and we go 11 and break it apart, we go 1 times 11, and that one's done. And then we can look at 40, and that doesn't break apart. We got 1 times 40, 2 times 20, 3, 4 times 10, 5 times 8, right? None of those match anything over here other than the 1. That's useless to us. Alright? So, what we do know, however, is that they both have an a term. Alright? Now what we're going to do is we're going to take the smallest exponent from the matching variable. Alright? So we're going to go a squared. Okay? Now, number 7. Number 7, okay? Well, number 7, we got 15. That breaks apart into 1 and 15, and 3 and 5. Alright? And then 35 will break apart into 1 and 35. And then, let's see, 5 and 7, and that's it. But what we have in common is they both have 5. Alright, so what we can do is we go 5, and then we're going to take the smallest exponent, even if it's a 1. Okay? So 5 times b k squared. And there we have it. Alright? Number 8. Number 8 is asking us to factor. Alright, so what we need to do is look at these numbers first. Okay, is there anything that goes into both 2 and 5? Well, we happen to know that there is nothing that will go into both of those numbers. But what we do have is this a squared and an a here. Now what we can do is we can go a on the outside of 5a minus 2. And there we have it. Now number 9 is just straight variables. But what we can do is go ahead and pull out the smallest exponent on the variables, basically. And we're going to go, well, we know that a has a 1. A has a 1 here, and b has a 1 there. So, a to the 1, b to the 1, on the outside of a, well, that first term is b, and the second one will be a. Now, if you're not quite totally 100% confident in this, what you can do is you can go like that, to double check yourself. Alright, so a, b times b is going to be a, b squared. Minus ab times a, which is going to be a squared b. And that's what we had originally. So we did it right. Now number 10. Number 10, we've got 6x and we've got 10. A number that will go into both 6 and 10 is going to be 2. Alright, so we got 2 on the outside of 3x plus 5. And there's nothing else that will go into those evenly. Alright? Number 11. Is there a number that will go into both 14 and 21? 7. 7 will go into both 14 and 21. It goes into 14 twice, 21 3 times. So, we can go ahead and pull out our 7. And then the lowest variable is going to be c. So let's see, 7c on the outside of 2c squared minus 3. And there we have it. Number 12. Alright, now, the number 12, we're looking for something that will go into both 6 and 9. Let's see. So that's going to be 3. The lowest exponent is p of 1 and q. So what we're going to be left with is 2p minus 3. Alright? Now, number 13. Number 13, that's going to be 2a squared b squared plus 10ab. Biggest number that will go into both 10 and 2. Well, that's going to be 2. And then, let's see, lowest exponent is a and b. Alright, so what we're left with is a, b, plus 5. And there we have it. Make that look more like a 2. There we go. Alright. Number 14. Number 14 has a trinomial. So, what can we find in there that will go into all three pieces of that? We got 7, 21, and 14. Well, 7 should go into all those. So we go ahead and put a 7 out here. Alright, divide that by 7. That's going to be y squared. Minus 21 divided by 7 is 3. Don't forget the y. And then negative 14 divided by 7 is minus 2. And there we have it. Number 15. Okay. Number 15 has 18, 12, and 36. Alright, this is where knowing your math facts is going to come in handy. Knowing how to multiply these things, or multiply, your basic numbers and manipulate them in order to get what we need. So we got 18, 12, and 36. 6 goes into all three of those evenly. So we got 6. Alright, no variables in common, so we can just leave that alone. So 6 goes into 18 3 times, so 3x. 6 goes into 12 2 times, so 2y. 6 goes into 36 6 times. And there we have it. Alright? Now, number 16. A number that goes into both 15 and 6. Let's see. I would have to go with 3. Alright, but I'm going to pull out a negative 3 on this one. Alright, now lowest exponent for the x's is going to be just plain x. Lowest exponent for the y's is y squared. That is a y. Alright, so let's see, negative 3 goes into negative 15 5 times. Alright, and then let's see, x times x would be x squared. And we don't need to bring over anything for the y squared. Minus negative 3 goes into negative 6 2 times. It's actually going to be a plus 2. And then xy squared, xy squared. There we have it. That piece is done. Alright, last 4 problems. We've got 17, 18, 19, 20. Now, on number 17, if you'll notice, there is nothing that goes into 17, negative 24, and 1 evenly. But there is something that will go into the x to the 4th, x to the 3rd, and x squared. What we're going to do is we're actually going to pick the smallest of the exponents concerning the x. So we're going to go x squared on the outside. Now, that's going to be negative 17 x squared minus 24x plus 1. Okay? X squared times x squared is x to the 4th. X squared times x is x to the 3rd. x squared times 1 is x squared. Alright? And there we have it. Number 18. Number 18. Let's see. A number that goes into 14, 21, 7, and 56. Let's see. What I'm seeing is 7. And then, let's see, we got a P here, a P here, a P here, but nothing here. Alright, that means that we cannot factor out a P. Alright, so we're just going to leave it as 7. Now 7 goes into 14 2 times, so 2p cubed minus 3p squared plus p plus, let's see, 7 times 8 is 56. And there we have it. Now, number 19. It says that a civil engineer needs the area of a rectangular lot to be 6x squared plus 5x feet. Factor this polynomial to find expressions that could be used for the dimensions of this lot. Now, we've got 6x squared plus 5x. Now, there is no number that will go into both 6 and 5 evenly. Alright, see, 1 times 6, 2 times 3, and 1 times 5. Nope, nothing other than the 1s, right? So, there's nothing there. Now, what we can do is look at these x's. So what we can take is x on the outside of 6x plus 5. And it's just that simple. So we got x and 6x plus 5. So it says to find the length and width if x equals 10. Alright, now the length, we're just going to plug this in for x. The length would be 10. And then we take the 10 and we're going to plug it in for x here. So that would be 6 times 10 plus 5. 6 times 10 is 60 plus 5, which is going to be 65. And there's the end of the problem. Alright, now the area of a rectangle is 21c squared plus 14c. Find the length and width if c equals 4. What are the actual dimensions and area of the rectangle? So, we got 21c squared plus 14c. Now, what will go into both 21 and 14? I see 7. And then the smallest exponent is c to the 1. And let's see, 7 goes into 21 3 times. C times c is c squared plus 2. And there we have it. So we got 3c plus 2. And then we got 7c. And there we have it. So 7c and 3c plus 2. Now, let's see. It says, what happens if, let's see, find the length and width if c equals 4. So we're going to take that 4, put it right there. Actual dimensions are going to be 7 times 4, which is 28. And then we got 3 times 4 plus 2. 3 times 4 is 12, plus 2, which is 14. And there we have it. Problem finished. And notes are finished. Oh. And almost forgot one little more thing. We got 28 times 14 to get the actual area. Sorry. So 28 times 14 should be 392. And there we have it. It's that easy, y'all.